Hello everyone, my name is Matthew Ramirez and I'm a cloud engineer at Nebulaworks. If this is your first time here, welcome to the Nebulaworks channel. This is the third video in our three-part series on Terraform repository best practices. If you haven't seen our first two videos, I suggest you go and do that. That way you can better understand the topics that we're going to be discussing today. So just a quick recap for our first two videos. In our first video, we discussed best practices regarding the layout of our Terraform configuration files, as well as an introduction to modules. In our second video, we discussed directory structure best practices, and we also discussed the characteristics of the various environments that you may be managing with Terraform. I provided the links to those videos in the description below. So in this video, we're going to be talking about releases and the release process. So the release process is going to allow us to walk over newly developed infrastructure functionality, so changes that we make to our Terraform modules, from our testing environments, so our dev environment, to our more stable environments, such as staging and production. So we're going to be talking about releases, what they are and why we need them, and we're also going to be talking about the release process and what that entails. So if you and your team are looking for a way to safely make changes to your more stable environments, as well as be confident that those environments are going to behave as they should, then I suggest you stick around. All right, so now on to the objectives. So today we're going to be talking about a couple of things. The first of those are Terraform modules. So we're going to see where Terraform modules fit in the release process. And next, we're going to be talking about releases. So we're going to be talking about what releases are and why they're so important. And lastly, we're going to be talking about the release process. So we're going to be going over the branching strategy that we use here at Nebulaworks, as well as our release process. So as for prerequisites, there are a couple of things. As mentioned earlier, I do suggest that you guys watch the first two videos. That way you can better understand the topics that we're going to be discussing today. I also assume that you guys have some knowledge of Terraform modules, so you should know how to use them. And lastly, I assume that you guys are familiar with version control system. So in this video, we're going to be using Git. But it may be different at your organization. But a good branching strategy and version control are central to the release process. All right, guys, so let's get started. The first thing we're going to be discussing are Terraform modules. So just a quick recap, a Terraform module is just a directory that contains Terraform configuration files. And also note from now on, I'm going to be referring to Terraform configuration files as .tf files, as it's a little shorter. So the .tf files that are contained within this module or directory define related resources that are usually, if not always, spun up together. So every time I want to, spin up this group of related resources, I'm going to call this module. So there are two types of modules. There are internal modules and external modules. So internal modules are modules that reside within the same repository as the root modules that reference them or call them. So let's just take a quick look at our directory tree here. So in this repository, we have an environment directory that contains several subdirectories. So we have our dev, staging, and production directories. And within each of these directories, we're going to have Terraform or .tf files that define resources for each of the respective environments. And these are the directories or root modules in which we're going to be running Terraform apply from. And each of these root modules is going to be referencing this AWS internal module. And we're going to flesh this out soon. But yeah, so this is an internal module here. So external modules are modules that reside in separate repositories as the root modules that are referencing them. So it's important to note, guys, that the release process we're going to be talking about today is going to be going over the release process for an internal module. Cool. So when managing our environments with Terraform, it's often best practice to have resources that are common across each environment be defined in modules. And this is best practice for several reasons. First, code reuse, right? We don't want to have to be rewriting code in every environment. The second reason is because we want all of our environments to look very similar for several reasons. The first of those is, I want to be able to test out new functionality across environments. It's better if all of our environments look very similar in that case. But I can achieve this similarity by making sure that each of my environments reference the same underlying modules. If I do have any resources that are environment specific, I can always define those as standalone in my root modules. And the last reason is because it allows us to enforce architectural patterns. So here at Nebulaworks, we use, here's an example. Here at Nebulaworks, we use GitLab for issue tracking and version control. So we manage all of our GitLab resources and members with Terraform. So Terraform has a GitLab group resource, and basically a group in GitLab is it provides us a way to group related projects, among other things. But this Terraform group resource, say, takes a lot of arguments. I say around 7 or 8. But here at Nebulaworks, we don't want people to configure like 6 of those arguments, right? We want to provide default values. So what we did to enforce this is create a group module. So whoever's using this module only has the ability to configure 2 out of the 8 arguments. So that's kind of an example of an architectural pattern. Modules are super important, and they are central to the release process because of the majority of the resources that are going to be spun up from our environment will be defined in there. So it's important that we're able to version them or cut releases for them. So that's a good segue into our next topic, which is releases. So releases you can think of them as a snapshot of our code at a specific point in time. And then this snapshot is immutable, so it means it can't change. So kind of getting more Terraform specific, we can think of a release as an immutable snapshot of our Terraform modules at a given point in time. Releases are really important to this process because it allows us to reference an immutable snapshot of our module from a given environment. So we know that that snapshot will not change and it behaves as expected. So releases are very important for a couple of reasons. The first of those is, one, provides stability. If I have my stable environments referencing this immutable snapshot, then I know that they will behave as expected because I can test out the snapshot. It helps me avoid drift. So if I run a Terraform apply on Monday morning, and then I run another Terraform apply on Wednesday night, I know that there will not be any differences, or at least any module-related differences, because they're referencing this immutable snapshot. Releases also help us, establish some expectations between product teams and our infrastructure teams in regards to the code that's being released into production. So when we have applications living in our environment, those applications may depend on certain resources or configurations in our environment. So if any resources or configurations are changed due to a module change, then things can get a little hairy. So releases give us a way to vet out the compatibility between specific versions of our applications with a specific version of our infrastructure. Those are releases. So now let's discuss the release process. But before we get into it, there are 2 important things that you're going to need before you can implement this. So the first of those is a Git branching strategy that allows for easy integration of any features that you have. And the second is a way or a process in place to validate said features. So you need a way to merge them back to the branch that you're running Terraform apply from as well. So just keep that in mind. So here at Nebulaworks, we use trunk-based development as our branching strategy. So trunk-based development is where developers collaborate on code in a single branch. So we call this branch the trunk or master. And this and our master branch is always in a deployable state. So we like to keep our branches shallow, and we also like to keep our feature branches short-lived. So I'm going to be going over this little diagram here so we can better understand what or how the trunk-based branching strategy workflow works. So let's pretend I have my master branch right here. And let's say I want to add a new feature to my module. So what I need to do is I need to branch off a master. So I create a new feature branch off master, test it, vet it out, and then merge it back in. Then if I wanted to create a second feature, do the same thing. Branch off master, add my changes, test it out, and then merge it back in. Now, you guys are often going to run into a situation where, let's say I start on feature 3, but when I branch out and I'm working on my feature, someone else has merged another feature back into master, or another feature branch into master. So what I need to do in this case is I need to rebase off master, pull all the latest changes, plot my changes on top, and then retest to make sure that the newly added changes have not broken any of my changes. So once I've, made sure that that's the case, I can merge that back into master. And yeah, that's a quick and dirty trunk-based development workflow. You have master. Every time you want to add a feature, you branch off of it, test the feature, and then merge it back in. So we found that this workflow or this branching strategy works really well with infrastructure development. Cool. So yeah, now let's get on to the release process. I'm going to scoot over here. So this is going to be pretty interactive. So this down here in this diagram, you can think of it as the release process across a sprint. And for those of you guys who don't know what a sprint is just a designated point in time where we define features that we want to add or work we'd like to complete. So this is our sprint. And then this right here is the Terraform repository that we're working on in this sprint. So we're going to be adding features to this, and we're going to be releasing features to this repository. All right, so let's get to it. So this is the start of our sprint. This is the end of our sprint. And this is our master branch. So at the start of our sprint, we have a feature that we'd like to implement. So we create a feature branch. And let's say this feature branch is basically the creation of a main.tf file and a modules.tf file in our dev repository, as well as a main.tf file for my staging and production environments. Cool. You know what? We can also create module.tf file here too. But it's important to note that there are no modules being referenced in our stable environments yet because we haven't vetted anything out. So that's feature 1. So for feature 2, we actually want to make changes to our module. So we're going to start adding stuff to our AWS module. So let's say for feature 2, I want to define some resources and add them to my module. So I'm going to define these resources in a file called resources a.tf. Right? So in order to test these changes out, what I'm going to do is I'm going to have my dev root module reference the local AWS module. So let's pretend, we get a purple marker here. So let's pretend that this is kind of like a close-up of our modules.tf file. So I'm going to have module blocks defined there, right? And I'm going to name it AWS because we're naming the AWS module or referencing the AWS module. And as for the source, I'm just going to reference the local file path. So I think it's like what? 2 directories up? Or yeah, 1 directory up. 2. Like that. And modules, AWS. So now that I'm pointing at my local directory, I run a Terraform init, plan and apply, and then, if everything works out as expected, then my changes are good to go. Then I merge feature 2 back into master. So now onto feature 3. What I'm going to do is, I want to add more resources to my AWS module. So I define these resources in a new file, and I'm just going to call it resources. And again, I repeat the same process in my dev environment. So what I'm going to do is run a Terraform init, plan and apply, test out the changes. If everything works as expected, then I merge feature 3 back in. So it's important to know, guys, that up until this point, all of the features and testing I've done have been done in the dev environment, right? So it's important. We have not tested any of these things or integrated any of these features into our stable environments, so staging and production. All I did was just set up the bare bones .tf files in these stable environments. So after the sprint ends, right, we did well. We got 3 new features merged into master. I'm going to create an issue. So you can create an issue in my case, I create something in GitLab or Jira. And this issue will deal with releasing the newly developed infrastructure functionality into our more stable environments. So that's what the issue centers around. So what I do at the end, after the sprint's over, is I would create a branch. Let's just call this branch MR. So this is my initials. So MR issue. Let's just call it issue 4 because this is technically the 4th issue. MR issue 4, and this number is kind of arbitrary, but this issue is going to be linked to the release issue I just mentioned. This branch, sorry, is going to be linked to the release issue. Then I also need to create one more branch. I'm going to call that RC 0.1. And RC stands for release candidate. So this branch is going to be used to cut the release. So at this point in time, my MR issue 4 branch, my master branch, and my RC 0.1 branch are all the same. Also, guys, I'm putting 0.1 here because this is my first sprint. So it's going to be the first version or iteration of our modules. Cool. All right. So now what I need to do is I need to integrate these newly developed infrastructure functionality into staging. So I'm going to need to go back to, oh, almost forgot. I need to push this RC branch to my remote. That way I can reference it in my modules block. So I'm going to need to go back to my MR issue 4 branch, and let's just pretend this is a close-up of my modules.tf file. I need to go in there and then edit the source. So in this case, my source is going to be, the get URL, and then the path to the AWS module. So I'm kind of skipping some directories here, but I don't have a lot of room. And then the reference is going to be RC 0.1. So I am referencing the AWS module in the RC 0.1 branch. So that's what I'm doing. So now that I have my staging environment pointed at the AWS module in my RC branch, I need to do the same thing I did in dev. Run a Terraform init, plan and apply to vet out the changes and make sure that everything's working as expected in my staging environment. And if everything's a-okay, which hope's the case, then what I can do is I can create a tag off of this RC branch. So this tag will be 0.1 because this is the first iteration, the first version. And also I'm going to point out, guys, that the difference between a tag and a branch is that the tag or the release is immutable, so it can't be changed. Whereas the RC branch can continuously be changed and have stuff added to it. So after I cut out this tag, I'm now going to have my production environment reference this new tag. So that's the next step. So I need to go back to my MR issue 4 branch and then purple. Change the source in my production root modules.tf file. So if I go here, go to modules, and I change the source. So we're gonna do this is the get URL, and then path to the AWS module. Skipping some dirs here again, and then the reference is the tag. So now that we have our production root module referencing the tag, I do the same thing, run Terraform init, plan and apply. And if everything goes well, as it should at this point, because my RC branch and my tag are one and the same at this point, right? They have the same code and the same changes. My production environment should behave. So what I do is I merge issue 4 back into master, right? Because issue 4 has the updated modules.tf references for both staging and production. And then once I do that, I can run a Terraform plan and apply from my master branch. So there is a reason why we prefer to have our staging environment or staging root modules reference the RC branch and have our production root module reference the tag. And one reason is because there is a thing called a hotfix. So in the event that our modules or the changes that we've made to our modules have a bug or don't work as expected and somehow they get through, we can do something called a hotfix. So what happens is, let's say we have a problem we spin up a branch to fix that problem. So let's call this branch just like hotfix. Say issue 5. We fix the problem, right? We test it out. We merge it back into master. Then what we do is we cherry pick the commit that fixes that issue onto our release candidate branch. So now our release candidate branch has the fix that's needed. And this is a minor. This will be like more of like a minor fix. If it's super major and kind of like requires a total overhaul, then I may just create a new release candidate branch to incorporate those new changes. But in this case, it's not too bad, so I'm going to just cherry pick the change onto my release candidate branch. So then what I do is I run Terraform init plan apply, make sure that the change works in staging, and if everything works okay, then I release another tag, or cut another tag, and I'm going to call it 0.1.1. So I push that tag to my remote, and then I have to spin up one more issue, and this issue is going to be centered around, or one more branch, and issue. And I'm going to call it issue 5, or 6 actually. And this issue is going to be updating the production root module with the new reference of the new tag. So I go back in, I go to my issue branch number 6, and then I update the reference to point at tag 0.1.1. So now I can run Terraform plan and apply, and my production environment should be behaving. And now it has the incorporated fix. So that's just a quick example of a hotfix. But yeah, guys, this is the release process we use here at Nebulaworks. And we found that it works very well with for our customers. Again, I want to stress the importance of having a good Git strategy, as well as a good, as well as a process in place to validate the changes that you're making to your environment, right? Before you can even think about doing this. So process is very important. Alrighty, guys, thank you for watching this video. This is the last video in our Terraform repository best practices series. So just a quick recap on the series. In our first video, we discussed best practices regarding the layout of our Terraform configuration, as well as an introduction to modules. And in our second video, we discussed directory structure layout best practices, and we talk about the characteristics of the various environments that we'll be managing with Terraform. And in today's video, we talk about versioning modules, releases, and then the release process. We talk about a safe way to walk over newly developed infrastructure functionality from our testing environments to our more stable environments. So I hope you guys learned a bit more about Terraform and picked up some best practices on using Terraform in production. If you guys would like more content around the HashiCorp suite or any DevOps tooling or processes, please comment below, as we're always trying to push out new content for you guys. Lastly, if you guys have any questions on anything that I went over in the video today, please contact us at nebulaworks.com/contact us. All right, see you guys next time.